So welcome everyone. So today in this video we'll be talking about finding the inverse of a function. So in this session we'll be talking about definition of an inverse function, examples of an inverse function, and we're going to verify the inverse function. So we can see in the arrow diagram that in an inverse function the original input will be obtained as an output. So that happens in an inverse function. So now first, let us read the definition of the inverse function. The definition of the inverse function is an inverse function is a function that reverses the effect of another function. So if you have a function f and if you put x in this function, that will give us y for sure, right? So if you put x in the function, that will give us y for sure. An inverse function, what will happen is that if you put this y in the inverse function, that will give us the original value, that is x later on. So that happens in an inverse function. So now let us consider a function f(x) equal to y equal to 2x plus 3. So in this function, if we put x equals to 1, then we will get 5 as the answer. So this happened when x was kept as 1. So that is why f1 equal to 5. That is why f1 equal to 5. And then that is also why f2 equal to 7, and that is also why f3 equals to 9. So this happened by keeping substituting x with the different values of x. So if we keep x as 2 in the function, that will give us 7, and if we keep x as 3 in the function, that will give us 9. So the order pair is 1, 5, 2, 7, and 3, 9, because when 1 was the input, 5 was the output, when 2 was the input, 7 was the output, and when 3 was the input, 9 was the output. So that happened in the given function. Now the inverse function is just the opposite of this one. In the inverse function, if we keep y as the input, they will give us 1 as an output. If you keep 7 as the input, that will give us 2 as an output. If we keep 9 as an input, that will give us 3 as an output. So that was what our inverse function is. Now let us solve a problem. Let us consider a function f(x) equal to 3x plus 5. So in this function, we will suppose y equal to 3x plus 5 first, and the next step would be is to interchange the role of x and y. Interchange the role of x and y means wherever there is x, we'll keep y, and wherever there is y, we'll keep x. So this happens by exchanging the role of x and y. So in place of y, we have x now. In place of x, we have y now. So now 3y equal to x minus 5. So we are just trying to solve for the value of y here. So y equal to x minus 5 divided by 3. So now let us recall what we did earlier. Y equal to 3x plus 5 was given to us, and then we substituted or we exchanged the values of x and y. So on exchanging the value of x and y, we will get y equal to x minus 5 divided by 3, and the value of y obtained after interchanging the role of x and y is the inverse function. So this is the inverse function of the given function, y equal to 3x plus 5. So this is the inverse function. Now this was the solution. Now we'll verify why our answer is correct. So we had f(x) equal to 3x plus 5 in the given equation. So now we will check the solution of this problem. We'll put several values of y in the original function f(x) equal to 3x plus 5. When we keep x equal to 2, this will give us 11. You can see how it is shown here. When we keep x equal to 3, this will give us 14. When we keep x equal to 4, this will give us 17. When we keep x equal to 5, this will give us 20. And then now what we are going to do is we are also going to put several values of x, and these several values will be the output. These output will be kept in the inverse function. So on keeping x equal to 11, we got 2. Now the point to be noted here is the same input we had got by putting the values of x in the original function is obtained. See, the same 2 is obtained here. By doing what? By keeping x equal to 11 in the inverse function, right? Now similarly, when we had kept x equal to 3 in the original function, that had given us 14, and when we are putting 14 as an input in the inverse function, that gave us the original value of x 3. Now the same thing here, 4 was the input, 17 was the output in the original function, and in the inverse function 17 is kept as an input and the same 4 was obtained as an output. So same thing for here also. When 5 was input in the inverse function, inside original function, that had given us 20, and when we keep 20 in the inverse function, that gave us 5. So now what happened here is, so as the name suggested, the inverse function is shown here. The output and input are interchanged. Now we can show this in an arrow diagram. 2, 3, 4, 5 is an input and the output are 1, 4, 7 and 20. So this is x. The first component is x, and the 7 component is fx. So 2 is paired to 11 because when 2 was kept in input, 11 was an output. 3 is paired to 14, 4 is paired to 17, and 5 is paired to 20. Now what happened in the inverse function? The values are interchanged now. This fx is kept as an x input, this is an input, and then this x will be an output. So 11 is paired to 2, just the opposite of this condition, and 14 is paired to 3. Similarly, 17 is paired to 4 and 20 is paired to 5. So we just now verified the inverse function because the original input is obtained as an output when we kept the original output as an input in the inverse function. So I hope that you are clear with this solution. Thank you so much for your time, and then you can give me a necessary feedback in the comment section, and then you can subscribe if you have liked my video. Thank you.